Okay, hello and welcome everybody to another month of the Austin Python Meetup. Thank you for being here with us today. We're going to shout out our sponsor, Antler, for giving us the space we have. They just moved offices, so this is a new office. It's going to make it a little bit homier sooner than later, but Antler is a pre-seed startup incubator for people who want to start a startup and don't have any money yet. I think they're having a new residency program in September. If you want to apply for that, maybe possibly get some pre-seed money to start your business. Thank you to them. Shout out them. And with that, that's all the announcements for sponsors. I'm going to hand it over to Alex to give us his talk with Apache Iceberg and Python. Thank you for being here.
Thank you. Hey, everybody. My name is Alex Merced. A little bit about myself. I am the head of DevRel at Dremio, where I've spent the last pretty much 4 years now talking about lakehouses and Iceberg, really all day, every day. So I remember basically 4 years ago, people, when I'd go to presentations, people would be like, what's a lakehouse? Then like a year later, people were like, okay, yeah, we get lakehouse. What's Iceberg? Nowadays, the questions I'm getting is like sort of, how do I do this whole Iceberg thing? Like, okay, I'm sold on the concept of it, but like, how do I do it right? Okay, because I've seen so many people maybe do it not quite as nice as they would have hoped. And this has kind of led me to write several books. So like last year, I published Apache Iceberg, the definitive guide with O'Reilly. Okay, and then right now, I just put the finishing touches on Apache Polaris, the definitive guide with O'Reilly, which is about Apache Polaris, which is an open source lakehouse catalog, which I'll mention that category very briefly today. Okay, but I wrote a whole book on it. And then I have a third book that just hit Manning's early access program called Architecting an Iceberg Lakehouse, which is more about the how. So these are what is Iceberg, what is Polaris, what's their architecture, how do they work? And then this Architecting an Iceberg Lakehouse is more like, okay, what is a lakehouse as a whole? What are the different layers of the lakehouse? How do I decide which components should be for my lakehouse and all these things? So links to all of these books are going to be right here where this QR code is. And I also have business cards that have the QR codes if you want them afterwards. But yeah, that's a little bit about who I am and why I spend all my time talking about lakehouses. Because I work for Dremio, who's the intelligent lakehouse platform. Basically, our company, all we do is we try to make doing lakehouses easier and faster. But why do I want a lakehouse? To appreciate why you would want an Iceberg lakehouse, you need to think about what's the problem that it's trying to solve. So as data in an enterprise grows, what happens is that, one, the company becomes much more departmental. Each department is kind of more separate and whatnot. And then oftentimes you end up with one or two situations where basically you have like one central data team that kind of manages the data platform for everybody. But then sometimes that central data platform becomes a bottleneck in itself because there's just so much going on. Or each department starts making their own data platform, but then everyone's using different tools and maybe even different clouds. So maybe we have one department, let's say the sales department is using Redshift and AWS. We have let's say the finance department is using Synapse with Azure. And then we'll say marketing is using BigQuery with Google. Okay, now in this case, this is like a worst case scenario, but that stuff does happen, especially when companies are acquiring each other and you've acquired a company that has a completely different platform, completely different place. But then what happens is that as you want to do enterprise-wide analytics at all these platforms, they kind of store data their own way, all really good stuff. But now I got to go move data from Redshift into my BigQuery or from BigQuery into this Synapse. And now that's all. One, increases the time that it takes you before you actually have the data in a way that you can actually use it for your own use. So it increases latency of getting your insights. Two, it increases your costs in the compute to do those ETL jobs, the egress fees when you're moving data between clouds, or even just like the requests to the object storage and the actual storage itself. So your costs are compounding. And that's ideal world. That's if the data is perfectly moved. All you've done is increase your cost and reduce your time. But then there's also the likeliness that there's going to be data inconsistencies in those jobs or things that go wrong and that create other bottlenecks. So it becomes, well, frictionful. So the idea is, wouldn't it be nice that if instead of having to move data between all these departments, they could share data, not because they all standardize on the same tool, because people have different opinions. Some people prefer using Snowflake. Some people prefer using Trino. Some people prefer using Dremio. Okay, but instead of having to standardize on a tool, what if we just standardize on the way that the data is stored? Okay, and do it in a way that all our tools can talk to. So the promise of a lakehouse is saying, you know what? Let's take your data lake, your object storage, and turn that into the data warehouse. So instead of moving into this integrated data warehouse system, what we're going to do is we're going to store the data as Apache Parquet files, because that's going to be sort of the ideal structure in a nice columnar way, ideal for analytics. Problem is, if I have like 1,000 Parquet files, there's nothing that just kind of tells me, hey, these 1,000 Parquet files, that's my orders data set. It just doesn't magically know that. So that's where a metadata layer comes into play. That's what Apache Iceberg is. It provides that metadata layer where it provides that context saying, hey, these 1,000 files are the orders-based data set. Here's some stats on all those files, stats on partitions of those files. So that way we can more intelligently scan through those files.
Is our schema kept there, et cetera, so that you know foreign keys, primary keys,
Um,
that sort of stuff?
Foreign keys, not so much yet, but it does track the schema. So essentially what you'll do, not only does it track the schema, it actually versions the schema. So you can actually evolve the schema over time.
I mean, there's 3 application areas: sales, finance, marketing,
Mhm.
are all heavily dominated by relational databases because of history.
Correct.
So there's a huge schematic problem,
Yes.
which the lakehouse people have always faced.
Agreed. Agreed. And the discussion of primary keys and foreign keys are things that are currently like undergoing proposals for the open source format to be evolved into the spec, probably in V4. I know some of there's other priorities in V4, such as certain changes to sort of the metadata structure as a whole, so that we can actually have less files per commit into the table. But primary foreign keys is something that has been discussed, and they're still kind of coming up with the right solution for. Because basically, as an Apache project, as soon as one person says, "Hey, I want to do this," 20 other devs are like, "Well, there's this issue, this issue, this issue." It takes a while for them to all kind of agree on the perfect
Well,
solution.
there's a huge amount of issues.
Yeah.
Got a columnar store in your model versus a row-based architecture and relational model, right?
Agreed.
There's a whole bunch of other implicit assumptions and transaction purity that has to be maintained or somehow expressed.
Yeah, and I mean, oftentimes, like that's where like something like a semantic layer can really play a key role. And a lot of, I mean, Dremio, we provide a semantic layer over your data, but it's separate from, let's say, like the lakehouse itself. It's just sort of another feature we offer. Cool. But we have the data files that store the data. We have the metadata files, again, that provide a lot of the information to allow you to interact with those tables like you would in a data warehouse. Schema, partition, how the data is partitioned. And a really cool thing is it actually tracks the history of how the data is partitioned. So you can actually have multiple partition schemes over history, which is pretty unique to Iceberg specifically. And basically tracks like column stats, things like that. So that way you can better like say, hey, this file isn't necessary for scanning. And you can skip a lot of the actual individual files for scanning for faster queries. But at the end of the day, even if I have tables, you got to secure the tables. And also when I'm like looking up, when I connect like Postgres or Snowflake or whatnot, my tool automatically knows that there's these 100 tables that are available. Why? Because part of the software is a catalog that tracks those tables, tracks who has access to those tables. So we need that as well.
So how does catalog differ?
Basically, in Lakehouse world, what's happened is that the metadata usually doesn't track anything cross tables. So the catalog will actually have the listing of all the individual tables and where their metadata is, and also know who the users are to be able to say, hey, this user has access to this table, this user doesn't have access to this table.
So metadata is
Table specific in this
basically
case.
schema for the tables.
Yeah, it's basically table level metadata. Well, catalog is, well, in this case, the catalog is going to be more like warehouse level.
Table.
Yeah. So basically the entire sort of, it doesn't track the individual data for the individual data set, but more like the higher level, hey, these are the data sets that exist and who has access. And then basically when you have these 3 pieces put together, essentially what you've done is you've reconstructed a data warehouse. You're like, okay, why did I do all that? Well, the benefit is that now the sales department who prefers just say using Trino, they can connect to that catalog and discover all those tables and run queries on them with their preferred tool. Okay, finance that likes using Dremio, they can connect to that catalog, run queries on all those data sets. So now they could be curating all that data with whatever tools they want. And when another department needs that data, they don't have to replicate it. They can just access it.
So I think I know the answer to this from what you just said, but just to check if I understood it right. So finance has some data that for whatever reason, sales and marketing are not allowed to look at.
Yeah, or it just may just not have been created there. And now they want to make it available to them now that they've created that particular data set, curated that data set from somewhere.
So if finance has data and they're only willing to put it in the lakehouse if they have a guarantee that nobody outside of finance can see it, this would guarantee.
Yep, because the catalog would manage access.
Will enforce
Yeah,
that.
and then with specifically with like Apache Polaris, just say one of the open source catalogs, you can actually create multiple catalogs within there. So you can say, hey, there's a finance catalog, a sales catalog, and a marketing catalog, and then each user can have like specific access to each of those catalogs. So you can control like, hey, this is this particular user, they're gonna have this level of access to this catalog. And then basically what they would do is they would just connect to it with their credentials using whatever tool. And basically what happens is that when the tool says, hey, I want to query sales, or I want to query the orders table, it's going to send a request to the catalog saying, hey, I need to know what the metadata for this table is. And it's either going to reject that request if the credentials don't work, or return the location. And then also the cool thing about Iceberg is that it has this feature called credential vending, where basically the catalog can be the provider of the storage credentials, and it'll create temporary storage credentials. So in that case, you'll have these storage credentials like S3 or Azure that only last for that transaction, and then they're basically disposable afterwards. So basically, it's extra secure because you don't have to give people permanent storage credentials. They just need to have access to the catalog, which is pretty cool. And right now, I think of the different open formats, I think Iceberg is the only one that has credential vending. It's only with the catalogs that actually implement it, which Apache Polaris is one of them. But cool. But that's what a lakehouse is. So again, the promise of a lakehouse is that now I can interact with my data in one place across multiple tools. Okay, which also means I could just do it. Instead of me having to always use like a multi-extensive, multi-node system, like a Trino or a Dremio that might have several nodes and cost a lot per hour. For small workloads, I can just use my laptop. I can go use like a DuckDB or a Pandas or whatnot and do certain transactions or run certain queries depending on what the job I'm doing. I can use the right tool for the right job.
So you're saying DuckDB, Pandas can actually talk to the lakehouse?
Yes. Yeah, because basically what happened,
can we connect like a different, like for example, Azure and also Tableau Lake to this? Or?
Yeah. Basically, the actual storage layer, the Iceberg is agnostic. So the storage layer could be Azure, could be Google, could be AWS, could be MinIO, could even be Hadoop. The only limitation would be whether the actual tool doing the reading and writing knows how to read and write to that storage layer. But generally for the three clouds, pretty much there's libraries for all the major clouds, pretty much in every language for every tool. So usually that's not a limitation.
We can connect to simultaneously, or it needs to be separate for each system,
Well, basically the catalog would be managing multiple connections. So basically if I'm running a query off my laptop because I have let's say I'm running a Pandas job right from my laptop, it would communicate with the catalog, while separately maybe someone doing query on Dremio would connect to the catalog, and the actual catalog service would be able to handle those multiple connections. And then again, theoretically, then as you scale it up, you could also do a load balancer and scale it up from there. And then for the most part, I think again, depending on which catalog you use, a lot of that those sort of scaling up issues are already built into the platform or the services that you can deploy. So Apache Polaris is probably furthest along with the Iceberg ones. There's also Apache Tino, Lakekeeper. But again, it just depends. They all have like Helm charts and things like that to help you in the
But how could they not do the PyIceberg without the I? What's wrong with this?
Yeah.
What's wrong with that?
Yeah, that's true.
Okay.
Yeah. PyIceberg, yeah. Oh, well. But I will talk about PyIceberg, and there'll be a lot of different Python libraries. So basically what I'm going to do for the remainder of this presentation is just go through many of the specific ways in Python you can work with Iceberg tables. Okay. So first we're going to talk about PyIceberg. So you can actually just download, and the cool thing with the PyIceberg library is that you don't even need a catalog or a whole existing lakehouse for you to try this out. It actually has like a SQL-like catalog, which will, instead of having to have your own catalog already ready to go, it'll just create a SQL-like database right there in folder or wherever you decide to designate it, and use that as your catalog. So that'll keep track of where the metadata is, and everything will just be written locally. So you can try it out and actually write some Iceberg tables and see what the experience is like reading and writing to them. Yeah, it's pretty sweet. Like that's going to be one of the things they want to work on in V4, because right now the metadata tracks all the locations of the files with absolute file paths. So that creates a problem when you like grab the folder and then drag it out somewhere else or try to email somebody, because it was originally designed for very large data sets at Netflix. So that they weren't thinking, hey, I'm going to move this, or anyone should be grabbing pieces of this and sending it over at email.
That's also a lakehouse and a bozo no-no, right?
Yeah, exactly. The idea is you really just want one copy.
Never move the data.
Yes, agree. So it's by design,
So
it's intentional.
queries over there and get subsets back, right?
Yes, I 100% agree with you. But then there's a plethora of people who want to do those small little tables that they can like email over. So they're trying to accommodate for that in the next iteration of that. Huh?
Why are you enabling the sending of Excel sheets? I just see it. I see it now.
Oh, I know. It's just like a lot of people who use another format called Delta. They'll do that. And if you're like, well, we want to do that too, so you get the demand.
If you're wanting to sell it to finance or you, and you can't do
Yeah.
that, that's probably going to be a deal.
I agree. I like
It just is.
like the current paradigm. If I wanted to send a table to somebody, what I could do is maybe give them the metadata location so they can add it to their catalog, which I think is a better paradigm because you're not having to make all these like
I mean,
physical
that
copies of data.
is the 30-year-old, 40-year-old paradigm.
Yeah.
That is called the World Wide Web, right?
Yeah.
You get an address and you give it to people and you go get things. Servers are there.
Yes,
Servers are standing by.
I agree. In today's very, very cloud connected world, like this isn't that big of an issue, but
But that predated your cloud connected world back.
oh no, I know.
Right?
Yeah.
It's very important that we try to get away from this pattern.
I agree. I mean, Iceberg at its core is designed to get away from that pattern. And the idea that basically you go through your catalog contains a reference to where the metadata is, and basically no one's moving the data. You're just using the metadata to discover the data, no matter where you are, where you're located. So in this case, if I'm on my laptop and I were to run a job, I would just connect my catalog. Now, with the way PyIceberg works is that you actually just create a YAML file in this particular location, right in your a subfolder of your root. And then basically what you do is you put all your catalog configs there. So this is an example of like a legit catalog where you'd actually point it to like where that catalog service is, provide any kind of credentials, any other kind of configurations that catalog needs. And this way it's aware, but you're not putting it in your Python code, all those kind of credentials and things like that. Okay, kind of like using a .env file, except you would have it in a subsystem folder, so that way it doesn't get checked into version control. But here's a version of using that SQL-like catalog. So in this case, all you're doing is just giving it a file location of where that SQL catalog should be, and literally just create a SQL-like file there, and that'll be your catalog for like local play. It's not meant for production, but it's really cool for like, hey, if I want to just try this whole Iceberg thing out and see how it works. Okay. But once I define my catalog, then literally in my Python code, loading the catalog is as simple as this: load a catalog, and then I'll just look up the name of that catalog in the YAML file and use those configs to connect. And then right away, I can just begin running transactions. So here I'm just getting the list of namespaces in the catalog. Here I'm getting the list of tables, and then it'll just print all that stuff out for me. Okay, and then I can read, I can write using Python. So Python right now is the second most developed API for Iceberg. So the original API was in Java. That one has super feature rich because everything was always kind of added there first. Python is probably the next. Rust and Go are catching up. Rust is like they're actually using Rust to speed up. So they're doing actually a lot of the things they had already implemented in Python. They have redone and basically used the Rust library as bindings to speed up certain things. But yeah, it's a pretty cool ecosystem. I find this project absolutely fascinating. Okay, and then here's like you don't have to use the YAML file. Like if you really wanted to, you could just define the settings for your catalog right there in the file. Of course, again, ideally you keep all those kind of details outside, but you theoretically can. Okay, so you can just see how that looks like there. Okay, here's just another example of like creating a table using PyIceberg. So in this case here, I'm just like defining some variables with the name of the eventual table. Okay, and then here we are creating the table. So basically what we did is we have a schema. So I'm saying, okay, if table equals catalog, create table. I pass in the name of the table and the schema of the table, and then it creates a table. Pretty straightforward. Okay, and then scanning a table, you literally just run table.scan. Okay, and then here we're basically going to list, and it's going to use arrow buffers. So here's one of the cool things I love about the way they implemented this. Are you guys familiar with Apache Arrow? Okay. Yeah. So yeah, Apache Arrow is a okay. So what's the problem with things like JDBC, ODBC? The problem is it's oftentimes sending the data as like row-based data. So if I'm using columnar-based systems, what's happening? I'm taking columnar-based data, serializing it into rows, and then reserializing it into columns. So that's one problem. The other problem is that there wasn't a standard columnar format. So between columnar systems, you're still having serialization and deserialization. So what Apache Arrow did, and actually one of the co-creators of Dremio is one of the co-creators of Apache Arrow, basically what they did is they created a standard way to represent data in memory in a columnar way that kind of minimizes the need to copy data in memory, also reduces the amount of size and space that you can have data, so you can process data a lot faster and process a larger amount of data in the same amount of memory. It's become it's become the industry standard. So Dremio was built top to bottom using Apache Arrow, which is one of the reasons why we have the performance that we do. But now you're trying to see everybody adapt Apache Arrow into their data products. So there's like Apache Data Fusion, so you big open source query engine that uses it. Snowflake has adapted certain parts of it. Spark has projects that are like improving its guts with Apache Arrows, projects like Apache Comet, Gluten, a couple others.
So in Python, there's been this big move to an array API, which
Mhm.
frequently is always implemented in Parquet Apache Arrow files.
Mhm.
So is this pattern moving into the array format also?
The two projects do work together. Apache Parquet and Apache Arrow work great together to keep all those data structures very similar. So that way, when it loads up when it's loading up those columns from memory, it would then represent them in memory in a very similar format. So that movement is very, very lightweight. So it can load. So basically, in Apache Arrow, if I were loading data from Parquet files, I'm going to do it really fast versus loading it up in some other in-memory format or in-memory structure.
So are the PyIceberg people going to support the array API? You're going to Pandas here, and that sounds like it could either be extremely lightweight.
No,
or
that
very heavyweight.
that's heavyweight when I convert to Pandas.
So that means you're not using the array API.
No. So so when I'm doing this, I'm loading it as an arrow buffer or an arrow table. So if you kept it in arrow and just use the arrow library to do all your operations, then it's super, super, super fast. If you convert, and I think in Pandas v4, they've added like Iceberg support, so I think they've addressed some of those issues. I have to kind of take a look at the implementation.
There's just been a huge transition for Pandas and NumPy and
Yeah.
all of their UPIs and all of the various numerically computationally intensive applications to move to a common array format so that these can all be very lightweight, mixed and matched.
The ideal world that would be where things move towards. I don't.
Well, all the numeric people have moved.
Yeah.
I mean, I was at Sci-Fi.
Yeah.
4 weeks ago. They've all moved.
Yeah.
Okay.
Okay.
So as is Dask and as is anybody else who does the data frame pattern,
Yes.
they've almost all moved to this array underlying.
Okay. I mean,
And so for example, when you're moving to your two Pandas, you could actually stay ridiculously lightweight if you were already on top of that pattern.
okay. Yeah. I mean, I have to take a look at the specific spec to the Apache Arrow versus the spec for the format that these other libraries are using. I imagine they're actually probably a lot closer than I expect they would be, because I know those I know those people are like, especially like Wes McKinney and others are. They all work together, and Matt Topol. They work together very closely on these specific things. So they're all having those conversations. But I don't know specifically how. I can't say you for a fact how it ended up going out. But I do know that when you load the Iceberg table, it's going to load it as an arrow table, and when you convert it to a Pandas table, there is a conversion that occurs there. How heavyweight or how lightweight that conversion is, I don't know how it is today. I remember like 2 years ago when I tried it out.
Oh, 2 years ago, as hell.
Yeah, 2 years ago when I did like measured the time frame and how long it took, it did add a decent amount of time to the total transaction process.
Huge change.
But yeah, but I haven't done that benchmark recently to say if it's still as heavyweight as it was once upon a time. But I do know there's definitely there is a conversion between formats when that happens.
2 years ago.
Yeah, correct. I know there's definitely been a lot of unification since then. Cool. Okay. Okay, so that's what's happening here. So again, we're loading the data into an arrow buffer, and then we're just basically using Pandas and turning that into a Pandas table. And then Pandas v4 is going to have actually explicit support. I mean v3. V3 is going to have explicit support. I was talking about Iceberg v4 earlier, but Pandas v3 is going to have explicit support for Iceberg. Okay, and here's just some examples how that looks like. Now, in this case, it's still working off that same PyIceberg.yaml file. So long as you have all your settings. At the end of the day, all these libraries I'm talking about, they're also just using PyIceberg. Why? Because why rebuild the wheel when you already have the official sort of Iceberg core API built? All you build your stuff around it. So you're going to see that a lot of these patterns just repeat themselves. But basically, you just name your catalog, loads it up in the PyIceberg.yaml file. Okay, and then you have these new functions, read Iceberg, which you basically just tell, hey, which table you want to read. You can apply some filters to it, and it'll return you the results. Okay, then you also have, well, those are just another example of reading it. In this case here, we're sending a limit. And then this one is just another example where we're pulling it from a SQLite catalog. Then you have a write. Oh, we're not at the right one yet. Okay, and this one, you're just doing the inline catalog properties. You're not even using the PyIceberg.yaml. We're just basically stating those explicit catalog pieces. Cool. Here's the example of the write. So again, now the new function is to Iceberg to write to a data to an Iceberg table. And again, these are all still experimental in v3 so far. So they're not like general access, or they're still experimental. Okay, and then you can append it to the table. So in this case here, you're saying you're a pending transaction. The benefit of an append transaction is that it'll be a lot faster because you're not having to go evaluate old files. Cool. PyDremio. Well, there's really two. So Dremio is another way you can interact with Iceberg via Python. So this would be very similar to PyIceberg, where basically you have this other engine running remotely, and you're just using Python to talk to that sort of remotely talking service. So in this case, like Dremio, what we do is that we're a lakehouse platform that connects. We're built specifically for Iceberg, but we connect lots of different data sources. So we connect to Snowflake, we connect to pretty much all the data warehouses, databases, data warehouses, and give one place where you can define a semantic layer over that data. But our query engine is very optimized specifically around how the Iceberg metadata is structured, using that Iceberg metadata to kind of help cache data and accelerate to, let me catch my words, to monitor the table and also accelerate data sets. We have a lot of really cool features. I won't kind of get into the Dremio piece of it right now. But the idea is that if you have Dremio and you're using Dremio, we have a couple different libraries you can use to work with it. Okay, and again, here's what Dremio is. So again, basically, we can connect all your data. We're a query engine. We have a built-in catalog. So that Apache Polaris project, we're one of the companies that actually has a built-in Polaris project. Also, Snowflake has a commercial Polaris offering, and I know of 3 other companies that will be coming out with one over the next 6 months. So very much looking like that's going to become the standard catalog because it has like the most sort of easy ways to kind of on-ramp to it. Okay, but again, here's an example of using PyDremio. So in this case, what we're doing is we're just going to load all your Dremio configs from the environment. So the specific, for that specific library, PyDremio, it has a bunch of different environmental variables you define with all your Dremio settings. So your Dremio URL, your Dremio path token, all these kinds of things. And then you can just run queries with it. So in this case, you're seeing here get dataset, which will just you just name the dataset and it'll just basically run a select query against Dremio. And the cool thing is it doesn't matter if it is Iceberg. It could be an Iceberg table, it could be a Postgres table, whatever you connect to Dremio, you would just work with it. Okay, and that's sort of the beauty here. So okay, and then here's just another example. In this case, what they're doing is instead of just saying get the dataset, they're actually running the SQL directly and running that against Dremio. Now, there's another library. Oh, I didn't include a picture of that library. There's another library called dremio-simple-query, which is actually a library I wrote that basically allows you to query Dremio, and it'll actually immediately load it up in your sort of format of choice. So I made it where you get like a to.db function, so it'll actually query Dremio and then load it up with a .db table, or an Arrow table, or a Pandas table, or a Polaris table. So it's basically you don't have to write all that logic yourself. It just does that for you. But I forgot to add that slide. I didn't have a slide for my own library. Oh, the slides must be out of order because they definitely added the DuckDB stuff. Okay. Okay, so here's Polaris. Okay, so again, now the difference with Polaris and DuckDB, I want to just talk about a little bit about those two specifically, because those two currently still can't use a catalog. So basically, it won't like connect to your catalog in your PyIceberg. The way they'll both work is that you actually have to tell it where the metadata file is. So every Iceberg table has a file called metadata.json. So if we were to think of the metadata as like a tree, you guys mind if I use the whiteboard? Yep. Okay. So essentially, what's going to happen is you have 3 layers of metadata. I'll show. At the top, there's a metadata.json file. This is the file that's going to have like the schema, the partitions, and the snapshot history. So at the end of the day, for any tool to really understand how to read this table, that's the main file that's going to look at. Because basically, if I'm running a query, what's going to happen is that you're going to point me to this file. That's what catalog is doing, just pointing me to this file. And I'm going to get to that file. I'm going to be like, okay, based on the query, I'm looking for a particular snapshot. So each snapshot has another file called a manifest list, which is an Arrow file, because they're row-based records. And manifest list. So there will be multiple snapshots. So basically, in this case, let's assume that you're reading the latest snapshot. Okay, so my query comes in. In this case, either the catalog told me to go find a metadata JSON, or in this case, for DuckDB or Pandas, Polaris, it's going to point me. I'm actually telling it to go look for this metadata JSON and getting the location on S3 or Azure for it.
It'll open up this file, find a snapshot, and it's going to find the address for the manifest list for the latest snapshot in this case. So now this manifest list is essentially literally what the name implies, a list of manifests. So that's not going to make sense if we don't talk about what a manifest is. So then there's a third tier of files, which are also Arrow, which are just manifests. Okay. But these manifests are the actual listing of the individual files. So it'll say, okay, here's this file, here's the location, the S3 address, here are the stats for each column, so the min, the max, how many records there are in the file, all these kind of statistics on the file for each record. How did I get that? Technically rolled up all the stats from the public file. So the Parquet file has all these row groups that have stats on the row group. We roll that up to a file level stack, put that into this file. Okay, then we take all those stats and we roll them up into an entry on this manifest list. So essentially, this is sort of like a summary of each group of files. So now Dremio or Trio or any of these query engines, they can take a look at these stats and say, this manifest, not relevant to this my query. Okay, based on my particular filters, I don't need to look at this group of files. Then, once I've filtered out as many manifests as I can, I'll go to the manifest. And then I can do the same thing. I can go to each file and say, hey, do I need this file, do I need this file, do I need this file? And then when I'm done, all I have left is just a list of the actual data files that I need to scan for this query. So I can have a data set that's 100,000 Parquet files, only need to scan 3 files. So that's why this works without a catalog, but you have to explicitly tell it what's the right metadata.json. Not ideal. I imagine very shortly both of these libraries will allow you to use a catalog. I don't know why they don't already, because it's right there in PyIceberg. They don't have to do anything, but apparently they do not.
Well, it's right there in Iceberg.
Yeah. Like it's literally in the PyIceberg library. So I can't imagine it would be a huge lift for them to add it, but they haven't yet. There's probably something about how their libraries work that precludes them from doing it yet. I have a feeling that for Polaris, it has more to do with the state of the Iceberg Rust library. But I don't know what DuckDB's reasoning is.
Or it's just not enough of a pain point to ever
Yeah, I mean,
to the top of the list.
yeah, it's not. I don't think for like a lot of people who use those libraries, it's like their most tried out feature. So they're not, it's not, but it's Iceberg is becoming a thing. Like it's just now pretty much. I can't think of any tool that hasn't really built in some level of Iceberg support nowadays. Or most data warehouses have at least built token ability to read like external Iceberg tables. Yeah.
DuckDB is a Parquet native.
Yeah.
Right. So basically, it really just needs metadata. Say, give me the table. I'll give you the Parquet file.
Oh, agreed. But let's say the table. Let's say this data set had like 1,000 transactions. It could have created 1,000 metadata files, and you have to know which is the right one. So that's where the catalog helps, because I might have like, because usually like at the most basic level, it'll be pretty easy. It's like V1, V2, V3, V4. Okay, I get that. But there are some engines that when they write the metadata file, it's not V1. It's like a hash at a timestamp before the .metadata.json. So then for like someone reading it as a human, I'm not going to know which is the latest one. Looking at a folder.
And it dissipated that. Okay.
Yeah. So that's another reason why it's at scale. You really do need to use a catalog. That and the governance piece, because people are like, yeah, you can govern the access to byte through S3 policies. You could, but you're still giving people sort of like credentials to have like permanent access to your S3 buckets versus giving them catalog credentials and make it temporary credentials. And you know exactly how they access the data and when they access those tables. It's just a little bit tighter security. Okay, I think that's the last slide. But yeah, so essentially, again, in summary, we want lake houses because we want to be able to work across different tools. And again, this is just the Iceberg story. Again, there are 4 libraries currently. Well, there's actually a C++ library too that's being developed. But the primary ones are Java, Python, Rust, and Go for Iceberg. And basically, tools that are being built on top of those. So like the Iceberg support is really expanding very quickly. But again, you can pretty much, another one I want to mention is a company called Bioplan. Okay, Bioplan is another really interesting company. What they did is they actually built a whole runtime specifically that uses Iceberg and Python. So essentially, literally, you can just install their library. I think it's just pip install Bioplan, BAUPLAN. And then what happens is that if you use their API, it'll just automatically just like hit their servers, and basically you don't have to worry about like how many nodes you need to run the job, or it just figures out all the infrastructure stuff for you. Like right now, because they just kind of came out of stealth, it's like free. So I'm assuming over time, as people like really like it, they'll start charging. But it's a thing you can use that gives you sort of like that sort of really nice, hey, I can just run it with Python and get that sort of like scalable nature out of the gate for free. I don't work for them. I work for Dremio. I just think it's a neat product. But yes, before I start rambling about anything else, first I want to open up to any questions about what we've talked about so far. Okay.
Online, see if there are any online questions.
Oh yeah, anyone online have any questions? Feel free to chime in.
I feel like I should be asking a question about HIPAA data.
Okay, so for very important, now security goes a bit beyond like all these data formats like Iceberg, Delta Lake, Apache Hoodie. They themselves don't handle the security. So like Iceberg, once you have the table, who has access to it? It's going to be dependent on sort of what tool you're using to actually query the data and how the different layers that people can access the data. So with Iceberg, the first layer of security would be your catalog. Problem is, the catalogs currently can only handle up to like RBAC, role-based access controls, mainly being because the way when you think about it, I can say, hey, this credential has access to this table, and then or they're part of this group that has access to this table, and that doesn't require me to read the data. Okay, but to do something like a row or column masking, we do need to read the data and then apply the rule. So in that case, that's often going to require an engine to enforce it. So right now, FCAC, fine-grained access controls, particularly lives in the engine. So Dremio supports fine-grained access controls, Snowflake, but the problem is, if another person and another access the catalog with a different tool, then those FCAC tools don't translate. The solution to that, which is currently being worked on, so actually Dremio, we put forth a proposal to the Iceberg community or I think it's to the Polaris, this is part of the Polaris project, of a sort of standard way of expressing those kind of rules. So the idea is that the catalog can store the expression, saying, okay, hey, here's the FCAC rule associated with this table, but then the engine can then pull down that and then apply the rule with those credentials. That's still, the proposals mostly figured out, but now like the implementation has to be built and then the PR's got to be merged in and all that kind of stuff.
I mean, I don't have HIPAA data now, but I have in the past had to worry. And anytime you talk about pooling data together virtually or literally, there's a chance that question.
I mean, those are actually the particular customers are like finance and healthcare, the two sort of like the sweet spot for us at Dremio, because we build that single access point that does have those rules across all your data sets. Hopefully in the future that gets implemented to Iceberg, and then it won't really matter what tool you're using. It becomes a lot easier. It's in my Iceberg catalog, whatever tool you want to use, it's secure. So there's a level of that now. That's a data lakehouse problem in general.
Yeah.
Iceberg is the first of the three projects that's really solving that in a holistic way. Like Delta Lake has a solution, but their solution is generally always like use Databricks. So which works if you use Databricks, but not if you don't. And then Hoodie is oftentimes used for like ingestion, but oftentimes people then end up converting to Iceberg or Delta Lake anyways. So I haven't really heard too much about security issues coming out of a project. Mostly it's always about speed and latency with them. Cool. Any other questions?
So yeah, back to the access. How do you give people access? Like you manage the access through Apache Iceberg?
You would do it through the catalog. So essentially, let's say
Would it be like, is it like OAuth or is it like?
Yeah, it could be OAuth. Yeah, so like Apache Polaris supports OAuth, and we're working on like that project is working on supporting different identity providers, so that way you have that flexibility. So yeah, you could use OAuth with most of the catalogs. I think support OAuth at this point. So you could use your own identity provider or use it as an identity provider, and then basically you would just provide credentials to your users. So ideal world, again, at least with our implementation of Polaris, you can, because Dremio supports, let's say something like using like Google as your identity provider, someone would just basically log into Dremio with their Google credentials. They can generate their token and then go put it into their credentials in their Iceberg workflows. But generally, I think all the other catalogs work in a very similar way. Not all of them support OAuth, but all the main ones do. And then, I mean, even AWS Glue can be used as an Iceberg catalog. So then, and then BigQuery, actually, I forget whether, is there the one who have Big Lake? I can't remember what their catalog is, but they're working on that. And I think they might have just added what's called like REST catalog support to their catalog. If it's not, hopefully they add it soon. Now, what that means is that when Iceberg was first implemented, the way catalogs work is every catalog kind of had their own library for how you interact with that catalog, which created a really splintered ecosystem. Because basically what happened is that every tool would have to create ad hoc support for each catalog. So if you're a tool like Dremio, where the connectors are built by the company, by the service, we would have basically, that catalog wouldn't be supported until we had customers asking for it. So what they eventually did is they created something called the REST catalog interface, which is a REST API spec, that if a catalog implements that spec, then any engine that supports the spec can talk to that catalog. So now you don't have to, like if you build a catalog today, as long as you implement that spec, you don't have to ask permission for all these tools to build support for your catalog. It just works, which is especially useful for companies that build their own in-house catalogs like Netflix. So AWS Glue definitely has REST catalog support. Dremio has REST catalog support. Apache Polaris has, most everybody does. Google may or may not yet. And then Microsoft still hasn't really have a Iceberg catalog store yet. They're bringing that out. But they made a recent hire that makes me confident that they'll figure that out soon. Any other questions?
Looks like you have questions on the.
Yes.
No, I don't think anyone should. No
No,
one sent a
Jakob is
message.
there. Jakob is waving his.
Oh, okay. Hey, go for it.
Jacob?
Okay, so I'm going way back with database systems that I know about 20-something years ago, even more than 20 years ago. Then there was a new thing called ODBC that allowed to connect different data systems, which is part of what you are solving. So in my old eyes, can I say, and you correct me if I'm wrong, that Iceberg allows you connectivity like ODBC plus credentials? Then that's the new thing that happened in the last 10 years or something like this. Am I correct, or did I miss something?
I would shift that a little bit, because the difference is that ODBC didn't define the way the data was stored. It would just connect to where the data is stored and be the way that the data is transported. So basically, I could still use ODBC today to connect to a tool like Dremio to pull that Iceberg data in there. So in this case, I would say Iceberg is more like the metadata in the database. So under the hood, Postgres is tracking metadata on every individual table that it uses to optimize its queries. Iceberg is more playing that role of the Iceberg of the table's like internal metadata. Now, what's more similar to ODBC is actually something that came out of Apache Arrow, something called Apache Arrow Flight. So Apache Arrow Flight is like a gRPC protocol for transporting data in a columnar in that Apache Arrow format I mentioned earlier, which Dremio, Snowflake, and a few others support. And then even better, they came out with a protocol on top of that called ADBC, Arrow Database Connectivity. And what that does, it allows you, like ODBC, to plug in a driver for a particular system. So that way, if there's another data warehouse that wants to transport the data in a columnar fashion, but it isn't Apache Arrow specifically, you can still plug in a driver for that system and transport the data columnar, not row-based like in ODBC.
So Iceberg does not handle the connectivity like ODBC, or does is part of it?
Correct. Iceberg is only a standard for how do you write the metadata. So
Okay,
yeah.
Good. This opens one more question that I didn't think about, but let's talk about my second question. Can you handle something which is not tabular data? Let's say object data or some tree data, or like, there are many types of databases today. Graph data.
Blobs don't currently exist as a data type in Iceberg. They just recently added a data type. They added what was it called? A variant. So it's sort of like a JSON, a much faster JSON data type. And then they added there was one other data type they added. And then there's other data types they want to add in the next iteration of the spec. But as far as like working with bigger unstructured data,
you cannot connect to MongoDB or Neo4j. Am I correct?
Well, actually, let me talk about Neo4j for a second. So if we're talking about Neo4j, we're talking about doing graph queries. There's actually a startup called PuppyGraph. Now, PuppyGraph is really cool. What they do is they create a platform that can connect to your data lake with formats like Iceberg. And if the data is modeled correctly, it could actually run graph queries on. So you could actually use Iceberg as a way to store data for graph queries using Puppy Graph. Now it won't. You would still like, let's say it doesn't connect to Neo4j specifically because Iceberg is its own way of storing data. But if you were to have like a column to define like your edges and your nodes and all that stuff in there, and then you go to Puppy Graph and define, say, hey, these are the columns to define these relationships, it could actually run graph queries using like.
So is Puppy Graph using Cypher or?
It's using Gremlin, not and another one. I can't forget, but not Cypher. Wait, no. Yeah.
Cypher is the Neo4j one.
No, yeah, it's not using that. It's using Gremlin and I keep forgetting what it is.
GraphQL?
No, not GraphQL. It's Gremlin and another language that I'm just skipping my brain at the moment. I would have liked to use Cypher because that one I know. Yeah, but that's what they use. And there's actually a cool tutorial. There's an open source like Docker image for Puppy Graph. So I do have the tutorial on dremio.com where you can actually like generate some Iceberg data in that graph format and actually run that query on there just to kind of see that in action. Because I like to write, I like Dockerized tutorials. I like it where you can run everything on your laptop and experience everything locally. So all my tutorials are kind of in that fashion. But
I think there was a MongoDB question.
oh, but yeah, basically Iceberg doesn't connect to other databases. You would take your data and then move it into the Iceberg format.
The thing is, it's kind of hard if you have a tree structure. Never mind. My third question, what AI capabilities are made simpler by using this Iceberg structure? Because I can see potential.
Oh, yeah. I mean, I would say Iceberg, I think, makes it easier. It's a great format for doing lakehouse. What I think really helps AI is the lakehouse pattern and the idea of just having your data in this nice open format, so that way you're doing less work to make the data available to your to your agents or other projects, because they're not working between. And then when you combine that with a tool, and again, just because I know this tool very well, if you combine it with a tool like Dremio that can connect to some of your other data sources, then basically it creates one point where your AI agent needs to connect to have access to your full data story. And then with the built-in semantic layer, providing it the context it needs to really provide sort of impactful interactions with your data. So I do think, one, having standardizing on Iceberg, regardless of what tool you're using to query it, really helps make sure that data across your enterprise is more quickly available for AI projects, because you're doing less sort of reprocessing of the data. And then I think Dremio accelerates that even further as another layer on top, or some sort of federation layer. I mean, again, I work at Dremio, but some sort of tool that allows you to kind of federate your data and define a semantic layer is going to then provide that next layer that really helps the AI.
So George sent me an MCP server of Dremio. So, but okay, this is a later discussion. If I was local, we could have talked hours on this. But George will tell you what I had in mind.
Got it. Okay. I mean, as a note, if you want to experience like have a really cool experience with that MCP server, we do bi-weekly workshops. Like I just did one earlier this morning, where you actually will get a full environment provision with an MCP server and Dremio, where you can actually like run queries and see that whole thing, everything in action.
Alex, I'm thinking of something bigger, but we'll.
Okay, we'll talk.
But we cannot talk in public on this.
Okay, understood.
Talk with George, he knows.
One question in the chat from Ivan: is there a significant difference between Unity Catalog, Glue, and Snowflake's Polaris, or the only difference is just a preference of where it's to host?
Okay, there are a couple differences to care about. I would say, as far as like all those are Polaris, and Polaris is actually technically a co-creation between Snowflake and Dremio. So basically, a fun fact. So it's actually both dev teams that built that initial code. But Polaris, AWS Glue, and Unity Catalog, I would say, are the three sort of main options. Now, as far as like if you're standardizing an Iceberg, Polaris is going to give you the most Iceberg-centric option, and it's open source. So like it's now Unity Catalog is open source, but most of the features, like the thing that Databricks does is that they often take the open source thing, and then the proprietary version of it is the same name, which kind of confuses things. When you read the docs for the OSS version versus the docs for the commercial version, it gets kind of tricky to understand which features exist and which ones don't. So oftentimes people will implement the OSS one and find out that a lot of features don't exist. So that's the one thing to keep in mind with like Unity. But if you're using Databricks and you're using the proprietary version of Unity OSS, it does have a lot of features that connect other things other than Iceberg data. Polaris is working on that. Polaris just added a new feature called generic tables. Essentially, what it does is just basically a quick mapping, saying, okay, hey, here's the name of the asset, here is the type of asset it is, and here's the location of that asset that you can use for other formats. So there's already some implementation for Delta Lake. I'm sure there'll eventually be, actually there is a PR for like Hoodie, and I'm sure there'll be a PR for pretty much every other variation of a data lake table there is, to have some sort of support for those other data lake tables. There's also going to be another feature that's going to be proposed called volumes for like unstructured data, where you can define like, hey, here's where I have a folder of audio or a bucket of this. And then you can, again, access control through your catalog, discover those assets through your catalog, whatnot. So the reason why I would be particularly bullish on Polaris, mainly because what happened with Iceberg. So let's say we flash back 3 years ago. The big thing was Iceberg versus Delta Lake, okay? And Delta Lake had more features. Okay, Delta Lake was because it was basically when you're a project controlled by sort of really one particular entity, you can iterate much faster. Okay, so it developed a lot of features really quick. But it's the ecosystem that didn't develop. Why? Because, well, I mean, and then again, the politics doesn't matter in the sense that if you're a company, you don't want to build your project in a format that another company controls because they can change that format overnight and break your product. Okay, so Iceberg was a sort of agnostic format that was community driven. There was no one person that controls the project, thus being an Apache project. It made more people in the ecosystem feel much more confident about building features around it. And then that ended up allowing Iceberg to accelerate its feature development and also accelerate its ecosystem support, which was the ultimate thing that kind of won the battle, and why eventually Databricks paid almost $2 billion for a small startup. One of the best stories ever. I am so they deserve it though. Such a good story, the tabular acquisition. But Polaris, you're starting to see the same thing play out. Okay, you have Unity catalog. It's more feature rich right now. But when you see the ecosystem, people are building around Polaris. So Confluent is going to be building around Polaris. Dremio is building around Polaris. Snowflake is building around Polaris. I know of 2 others that I'll probably announce soon that they'll be building around Polaris, and a couple others. So it's going to be the thing that you see in different projects. And the reason why that's important is that once there's a standard catalog, then all those features for things outside of Iceberg become easier to standardize. Because right now, AWS does other non-Iceberg things one way. Unity does non-Iceberg things another way. And then Polaris will do non-Iceberg things the Polaris way. Whichever catalog wins will be how every other tool builds their non-Iceberg support. So looking at if history is prologue, it makes sense that in the next couple of years, you'll see sort of Polaris take that spot. And then you'll start seeing everyone, and then you really will have that lakehouse. Dream of the lakehouse, where you actually have one catalog that controls access to all the things. In a couple of years. But we're getting there. It's an exciting time. I find this space is really exciting. The level of transformation of sort of really creating sort of unified access to everything, but also just the politics of it is also just much more interesting than I ever would have ever dreamed of. Good times. But yes, hopefully that clarified what the question was. Huh?
He says that.
Yeah. Thank you, Alex.
That was a whole story, but I have stories. Any other questions?
How do the engines for the SQL computation interact with Iceberg?
Got it. Okay, so really what matters is that the engines can support reading Parquet files at the end of the day. Because what's going to happen, like, again, it'll be slightly different depending on the engine, but like I'll give you an example of sort of what's going to happen on the Dremio. The first part's the same regardless of the engine. That's the whole like, hey,
You said you create X table. It's going to go to the catalog and say, hey, where's the location for that table? And go through the metadata. And at the end, it's going to generate a list of Parquet files. Then it's just going to read the Parquet files, load it up to however, and then basically process that query, however that engine can process the query. So you're going to get varying performance between engines. So that's why, like, whenever I see, when you start seeing battles between the different table formats, and they will put out like performance benchmarks, or go to that because it's like painless, because if you saw different tools, it'll give you 20 different results depending on which tool you use. But at the end of the day, it comes down to the format. All it's going to do is allow you to generate a list of Parquet files with the data. And the next step is the engine then reads those Parquet files and then processes the query, however it's going to process the query. So Dremio will load that into an Apache Arrow buffer in memory, and then basically run all the computation. from there, while other tools like Trino would run it into its proprietary or its specific format, in memory format, and then process it. And Snowflake would do something. So, that clarify?
Yeah, so it's kind of a layer in between the data and the engines. So you could use many different engines. They all kind of go through this Iceberg
Correct.
catalog. And then,
Yes, basically it is you're removing sort of the metadata layer that would normally be built into the warehouse. Where like Snowflake is keeping up all its own metadata on all the Snowflake tables and stuff like that. We're just pulling that chunk of functionality out and saying, here, put it in a place with all the engines going to use the same metadata to optimize the queries or to discover the list of data that you can access, and then let the engines figure out how they want to optimize for it.
So the modern architecture then is an Iceberg array of a bunch of Parquet files, a catalog, and metadata, all this stuff. That you bring your engine into the region that has the data. And then you can run your arbitrary queries there, and it has fast access to the tables.
Yeah,
Answer the query.
yeah. Ideally, the engine should be in the same region as the data. That was
So they're not going to take egress fees or any of that.
Yeah, like if I were like, that's one architecture that's oftentimes like people when people deploy something like that, like Dremio and the same goes for like Starburst or stuff like you can choose to sort of use all this. You would choose it to be in the same region as this. Where your data boundaries are. So those egress. Because if I were to query, if I were to deploy Dremio in Azure and then query Iceberg tables that are stored in AWS activity, so
Where your space going between Virginia and San Francisco.
yeah. So that's true. So you still think about sort of like where do I deploy my compute versus where I store my data. But ideal world like architecture should be that hey, this is where I'm storing data, and that's when I'm going to pull my data. And then
So what about replicating the data stores into dynamic spaces? Because Iceberg
okay, that's a fun conversation. So I mean, Iceberg doesn't do anything specifically right now. So that's just comes down to the storage branch. Like, what does S3 do to provide redundancy?
S3 gives 11 nonstop.
Yeah, but I mean, theoretically, something goes wrong. It comes down to sort of your particular storage level.
But smart people.
Yeah.
The data is in multiple.
Yeah. So I mean,
So somehow that has to be covered.
yes, and that is a point. That is another reason why the relative paths are in play. Because right now, I can't just arbitrarily copy that bucket over to another bucket because I have a path to change. So that case in the future with V4, it'll be much easier. Because right now, what I would have to do, there is a Spark procedure where I go in there and write the metadata with the new file path. So if I want to make that copy into a bucket, I would basically first copy the metadata and then copy the files. And then since I've changed the relative path in those metadata, all the file paths should match up. But that's I wouldn't be surprised if some of these vendors build that into the product. That's still like a problem that shouldn't be a problem. So before, once you have relative file paths, then you would theoretically just copy your data within the bucket because the file paths will be out. But instead, what I've had really have like one prefix, like the first part of the paths within the main metadata file, and then the file paths and the individual metadata file can be stored in the remainder of the file. There's things you lose doing that because right now the cool things you can do right now with Iceberg, it doesn't have an absolute. You can have files that are outside of like the folder where you have the table. That was useful when people were migrating because they would have like existing Hive tables and they want to move it to Iceberg, but they didn't have to rewrite all the data. So then they would just write metadata and then all the data going forward, you would write 8,000 that folder. They would still have all the access to previous locations. But that was really out of the person. And that's fine.
So this sounds complex for what is a very common pattern.
Yes.
Taking one's data is a very
100%. 100%. That is one of the questions I've been getting a lot. And I've written a blog, and I just literally that third book, Architecting Lakehouse, I literally wrote a whole chapter specifically dealing with some of those.
We also have storage hierarchies, right?
Yeah.
In addition to there's things like glacier storage, right?
Yeah, I mean that shouldn't affect things to the extent that it only affects things if the path changes. The path changes.
Oh, sorry, they change.
Yeah. So again,
Again, looking at data that's 10 years old, we may not want to actually highlight data. High latency, low latency access. Right?
yeah. I mean, I know some of the tools out there do manage that somehow. I'm sure it's like that. At least particularly S3.
Basically, wherever there's a cost value, it better be managed. Right?
Yeah.
Now maybe that's a Dremio feature, not an Iceberg feature. Totally legit that it's a Dremio feature.
I mean, I don't know if Dremio manages that specific thing. We do manage a lot of things, and there's other vendors like Rift. Their whole play is they're not even managing, they're just kind of, and they're not even catalog. We just do the management of these other things. Tyler only to see this, they handle a lot of that. But I mean, I don't have specific answers for like how you would execute that on the static of current data store. It should be much easier to do. That's one of the things again. But it is a challenge. I would say specifically right now the main challenges are going back replication of disaster plugin to FCAP, which there's a solution on the data right now. And then 3, what happened with stuff beyond that, which once the catalog was become standardized, then that becomes different. And my prediction, which I know for a fact is going to happen, so I guess it's not really a prediction, it's happening, is that all these data catalog them. So that's also the thing I think that they call this particular feature of catalog, because there's a whole other category of commandments, whatnot, but they use them different, but also don't have. So they're providing this listing of all data assets. That's because that's the data sets. They are all those companies that people don't know, or that you probably go to the various kind of into the dollar. So they can act as related kind of languages. Which that I think makes what will inevitably happen. Yeah.
A slightly different question, just to see if I'm thinking about the level of abstraction you're at correctly. We've got, say, finance department's data is on Azure, unless it's more than 2 years old, and then it's still living on AWS because that data never got moved. Is this product able to handle that for me, so I don't have to think about that fact?
You can.
What level?
The catalog can track references to different storage. So basically, I can have, like with Polaris, I can actually have different catalogs that point to different storage buckets. So I can have this catalog that points to a particular that stores stuff on Azure, and then this catalog here that points to AWS.
But does the person who's doing the query for the last 5 years of data need to know that, or is able to figure out, okay, past this date, I need to go to this other data source?
It won't be that granular. It will be more like, hey, this table is in this catalog, and this catalog refers to this particular storage. And it will generate the credentials for either Azure or AWS, in which catalog you're using. It'll probably get more granular as the project gets developed. Like the project is like a little over a year old, but it does have a mechanism for that. That still won't address us with user fees depending on where the computer is actually. But
Sure,
but the users have.
But the main thing is that I was thinking of is there's a lot of cases where the user doesn't want to have to know.
Oh yeah, they won't have to care about it. Yeah, basically you just give them credentials to the Polaris catalog, which you either do some service that you self-manage, or you get yourself a Dremio, or through one of these other companies that are going to have Polaris in there. And then you would just generate credentials to your user, say, hey, they have access, this level of access to these catalogs, and they would just, whatever tool they're using, whether players and when they're credentials, and they have access to them, regardless of where they're physically located, all that stuff is just accepted. And then ideally in the future, they'll even be able to see things that are non-active. So have access to, that'll be their team to their curated data. Which will be a pretty cool when it happens. Not there yet, but almost. Like we're definitely a lot closer to that than we were 4 years ago. And I was like pretty excited about this stuff then too. So
That seems like that might be the selling point for a number of organizations, is people who don't want the data is in 50 places and they don't have to remember where it is.
yes, that is definitely the selling point of, well, one of the selling points of Iceberg, the selling point of these catalogs. Part of Dremio separately, and Starburst are really kind of in the same space. But yeah, I mean, data unification is a big thing. The lakehouse pattern specifically, I think, does a lot there. And then when you add something like a catalog that can go beyond just your lakehouse tables, you get into an interesting place of data for the unification. You still end up in the world of, hey, does everyone just work on the time about catalogs? But hey, at least I know I can bring it to where to know that. And it's a better way of it.
I don't want to be good for patio.
Yeah, that's fine. I mean, I don't need, well, actually, I guess it'll affect the people who are watching online. So you guys have a few more minutes for you guys to hear my voice more, but I'll just keep going until the battery dies. We will have questions. But I like that console, so ask away. And if you're asking social names, okay. Otherwise, I know.
How about we thank him for the wonderful from the obviously chat.
Yep,
here upstairs. So
I'm just going to put up that QR code one more time for anyone who still wants to scan it. And then, yeah, so anyone who wants to scan it, there it is. Let me just hit slideshow.
And then, yeah, there I go into all the guts of the Iceberg format and the Polaris catalog and all that fun stuff. It's really what I go to sleep having dreams and nightmares about, and when I wake up, and it's what about. No problem. Yes, yeah. So it's a nice GitHub page that I can just quickly edit it when I need to with whatever links are relative to where I'm at. You'll find other cool links there, like there's some demo stuff there. There's also some links to like other meetup groups where you can discover Iceberg events all across the country.
yeah, you said you have one every 2 weeks for the
Yeah, that's the online workshop. So that's specifically a Dremio workshop that you can find. You just go to dremio.com to find it. We just added a cool interactive demo right there on the main page. And then the workshops, you get a full-on environment to play with. And the way they set it up is really, really cool. Because right now, typically, you would kind of like self-deploy Dremio. So it's like, it's not, we do have a SaaS version, but we're going to make, you'll see in a few months, it's going to get really interesting. But the workshops really give you an easy way to experience what it would look like fully deployed. I'm really excited to set that up. Cool. And then you go custom FCP client, so that way you don't have to like configure your own cloud desktop. There's just a cloud FCP client that you just that's automatically connected to Dremio with the tool set up. Super neat.
George, when are we thanking our speaker?
We just did.
Just
We
did.
missed it.
This wasn't enough.
This wasn't enough.
No, we need to do some noises and something. It wasn't noisy enough.
Yes, we all clap. Here. You just didn't hear.
It wasn't recorded. Guys, you didn't clap loud enough. I blame you.
You don't hear us.
Okay, can I stop the recording?
Yes.
Yeah.
Okay, stopping now. Thank you.
Thank you.